Hello. Hey. No, no. Now's a good time. It's going great. It's going really, really well. I mean, YouTube, the whole thing. It's really been a learning experience. Yeah. No, good response. Strange, but what are you gonna do? We're all doing our best. What? Get bacon mug? Oh, no. I mean, yeah, he's right here. You want to say hi? Yeah. No. Yeah. What? Say that again. Sponsorship. Other novelty mugs. I mean, I really appreciate it, but he and I have been together in this thing since the beginning. It's a package deal. How much? No, I heard you. I heard you. Oh, well, look, definitely something that we could talk about. I I will definitely give it some thought. Good talking to you too. All right. Bye bye. Okay, good morning, guys. We're going to start something new, but I want to let you know that I'm going to keep it relatively short today because tonight's homework is the quiz. And I want to let you know that that is the primary objective for today. Don't forget the importance of going back and reviewing that homework. Also be aware, if you're watching this before conference time, I will be available for conferences today from 10:30 to 11 a.m. If you go back and look at yesterday's video, I've put bugs on the screen to let you know both the homework that you need to know and where you can find that conference information. So what we're going to do today is combine a couple of things that we've talked about so far. So essentially with all of these, what we've been working on doing is learning how to factor so that that factoring can allow us to solve more complex kinds of equations. In this case, quadratic equations. And remember, as we talked about before, quadratic equations is really just a fancy way of saying any equation that has any variable raised to the second power. So in this case, x squared minus 2x minus 3 equals 0. Without getting into it too much, what I want you to understand is that it's hard for us to solve here because we have x's that are at different degrees with different exponents. So how can we go about solving that? So there's a couple of things that I want you to think about as clues that are going to help you out here. First off is that this equation is set equal to 0. You're going to see in a minute why that matters. So based on the factoring that we were doing in the past, we can look for numbers which multiply to -3, but which add to -2. So we can actually factor this into two binomials, x minus 3 times x plus 1. And if you're curious, you can FOIL this back out and see how this turns into this. Now think about this for a second. Anything that I multiply by 0 is going to make the entire thing itself equal to 0. So if you think about this for a second, if I'm multiplying these two things, each of which have an x in them by itself, would be pretty easy to work with. If either of those was equal to 0, then it really wouldn't matter what the other one was. The total, the product of the two would be 0. So what I want you to start to wrap your head around here is that there can actually be more than one solution to a quadratic equation. And by splitting it into these little binomials, we make it easier to determine which one. So I want you to imagine that we're going to do one version where this side is equal to 0. And I want you to imagine that we're doing one version where this side is equal to 0. And then all we're going to do, kind of like we did with absolute value equations, if you recall, is we're going to set both of those equal to 0, and we're going to solve for the various values. So we're going to pretend like this doesn't exist for a second, and we're just going to make it seem like x minus 3, just this part, is equal to 0. Because remember, if this is equal to 0, and it really doesn't matter what the other part is, we're going to end up with 0 on this side. So easily enough, we add 3 to both sides, and we get one possible value of x being 3. Think about this for a second. If I did 3 minus 3 here, then I'm going to end up with 0. It really doesn't matter that this one is 3 plus 1, which equals 4. 0 times 4 would still be equal to 0. By the same token on this side, x plus 1 equals 0. Subtract 1, and I get negative 1 as another possible value of x. So if you look at this solution set, negative 1 and 3, what it's basically saying is that if I plug either negative 1 into this original equation or 3 into this original equation, those values will both work. Just to show you quickly, 3 squared is 9, 2 times 3 is 6, 9 minus 6 is 3, and then 3 minus 3 again gives us 0. I could do the same thing with negative 1, but I'm not going to bore you with it. I said I wanted to try to keep today's video relatively short, so this is the setup. You're going to notice as you go through the notes, which have also been added to Schoology today, that there are some more complex examples, but I'm actually having you stop today after only 4 examples, because I just want to bite off just a little bit of this today, because remember, you don't have any homework over this tonight. Tonight is the quiz. Remember, you have 3 takes. Make sure you stop when you feel like you're at the best possible score you can get. If that takes all 3, then it takes all 3. Keep this in mind, because when we talk tomorrow, we're going to get a little bit more in depth with this. But take a look at the examples. There is not a supplemental video today, because I'm going to wait till we get a little deeper into it until we talk about tomorrow. Good luck on the quiz. I'll be keeping an eye on how you do with that.
Golden brown, fine temptress, through the ages she's heading west. From far away, stays for a day, never afraid.